Hello everyone, very good evening to all of you. It's Mayank this side, and I'm back again here with the basics of new topics, factors and multiples to be one. And if and as we get done with it, we'll immediately try to learn the basics of division and remainder. All right, so let us start. So, factors and multiples first. Okay, so let us see a couple of numbers. 12. So we will have the number of factors. Okay, first let us see the factors, then the number of factors. Okay, so 12 has what factors? So 1, 2, 3, 4, 5, no, 6, and then 12. Okay, a small tip here. As you are counting factors for any numbers and you reach its half somehow. So as I was counting factors of 12, I reached 6, then I don't need to seek any further. I can just directly write 12. Anyway, so there are 6 factors. Okay, let us see 18. 1, 2, 3. Not 4, but 6 and 9. So I have reached the half. So I can directly write 18. Again, 6 factors. Okay, let us see 36. 1, 2, 3, 4, 6, 9, 12, 18. I have reached the half, so I should directly write 36. So how many? Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9 factors. Alright, so there should be a mechanism to be able to count factors without literally manually forming them and counting them. So the thing is that right now, these are smaller numbers. We can afford to check and count factors on fingers. But what about the numbers like 360? So what factors does 360 have? 1, 2 also, 3 also, 4 also, 5 also, 6 also, 8 also, 9 also. That's insane. 10 also, so 12 also, and we have not even reached 1/30th of the number. So there are too many factors. There should be a limit to it, and there should be a mechanism so that we are able to count without literally counting them. Okay, so the thing is prime factorization. Prime factorization. So we know how we factorize. So suppose I have to find the prime factorization of 12. So I will start like this and then like this. However, I do not really like and appreciate doing this because the kids do this. And when you are preparing for competition, I always feel that if everybody knows something, if everybody does something, then it is as good as nobody knows it, or it is as good as you do not know anything special, or you do not have an edge. Okay, so save time and save space and save mental energy. So 12, can't you think it is 4 into 3, and 4 is made up of 2, so it's 2 square into 3. Worst case, you will take it 6 into 2, then write 6 into 2, then further 6 as 2 into 3 and all. So, okay, 18 is 9 into 2, so 2 into 3 square there. Okay, so we will take the case of 18 a little later. So let me first take the case of 2. So 12, sorry. So I have, in case of 12, I have 2 square into 3 to the power 1. Now if I have 2 square, so I can say 2 square is a factor of 12. If 2 square is a factor of 12, then 2 to the power 0 is a factor of 12, 2 to the power 1 is a factor of 12, 2 to the power 2 is a factor of 12, but not more. If 3 to the power 1 is a factor of 12, then 3 to the power 0 is a factor of 12, 3 to the power 1 is a factor of 12. Okay, how many pairs can we make through these subsets? So you see that one pair can be made like this. One pair, another pair. Okay, one pair with this, another pair with this, and the third pair with this. Okay, so how many are we going to make? So we have 1 into 1, 1. Okay, 2 into 1, 2. Then we have 4 into 1, 4. We have um, okay, 1 into 3. So we have 3. Then we have 2 into 3. We have 6. We have 4 into 3. We have 12. So look at all the green numbers. Have we found all the pair, all the factors? 1, 2, 3, 4, 6, 12. Yes, pretty much. Okay, let us see the case of 18 also. Okay, so when I have 18, 18 has 2 to the power 1 into 3 square. So when I have 2 to the power 1, I have 2 to the power 0 or 2 to the power 1. With 3 square, I have 3 to the power 0 or 1 or 2. Similarly, if I make pairs, I have 1 into 1, 1. 1 into 3, 3. 1 into 9, 9. Then 2 into 1, 2. 2 into 3, 6. 2 into 9, 18. So do we have all the factors of 18? 1 we have, 2 we have, 3 we have, 9 we have, 6 we have, and 18 we have. Yes, pretty much all the factors I have. Okay, so this works. This works. And you just saw how factors are actually formed. Okay, so let us now try to create a, a standard for it. Okay, so every element of one bracket multiplies with every element of another bracket. Okay, so in case of 12, first bracket had 3 elements, second bracket had 2 elements, so they made 6 pairs. In case of 18 also, first bracket had 2 elements, second bracket had 3 elements, so they made 2 into 3, 6 combinations. Let me check one more number. 36. This time I'm not going to make all the pairs. So I just see how 36 is 6 into 6. 6 square. So basically 2 square into 3 square. So if I have 2 square, I have 2 to the power 0, 2 to the power 1, 2 to the power 2. 3 in the bracket. In case of 3 square, I have 3 to the power 0, 3 to the power 1, 3 to the power 2. 3 in this bracket. Okay. So 3 here and 3 here. How many combinations, how many pairs are possible? 9. 9 pairs are possible. So 9 combinations are possible. So it would be like 1 into 1, then 2 into 1, then 4 into 1, then 3 into 1, 3 into 2, then 3 into 4. And yes, there are 9 factors of 36. So this is actually working, isn't it? Right? So now that we have found, let us find out the factors of 360. Okay, 360 is 36 into 10. We just saw 36. This is 36. And then we have 10. So 2 into 5. So in the next line, I can properly write 360 as 2 cube into 3 square into 5 to the power 1. Okay. So when I have 2 square, I am going to have how many? How many in the first bracket do you think? In the first bracket of 2, there are going to be 4 elements. In the bracket of 3, there are going to be 3 elements. And in the bracket of 5, there are going to be 2 elements. Alright. So how many, not pairs this time, triplets this time, how many combinations will be formed? 4 into 3 into 2. There are going to be 24 factors. That's quite a bit. 24 factors of 360 are going to be formed, right? So just imagine if you were supposed to actually count the number of factors of 360, counting 24 factors one by one would have made you a little more insecure because there are too many. So when you become insecure, you become slow, right? And there are more chances of making mistake. There are chances of missing some. There are chances of counting something which is not there, etc., etc. So we have understood this. I will write this in the form of a formula, but before writing the formula, I want you all to please try and find out the number of factors of the number 540. Okay, Aditya, sure. I will shift the screen if this is what you mean. Okay, so kindly find out the number of factors of 540. So far I have 7 answers and all are correct. That's really good. Keep it up. Simran found double the number the actually there actually are. Simran, please try again. Yogesh Joshi, you also found a little more than required. Please check your answer. More answers coming. Mostly right. Even the wrong answers are, they must be like wronged in hurry. So please be patient and check. You will be able to find your mistake. A lot of answers. That's really thrilling, and that's amazing. That almost all correct. Okay, so 540. You first look at writing it as, so 9 into 6 is 54 and then 10. So I have 3 square, then 3 into 2, then 2 into 5. So basically I have 3 to the power 3, then 2 to the power 2, then 5 to the power 1. So it looks like 360 only. So now the first bracket is that of 3, 4 numbers in that bracket, 3 in 2's bracket and 2 in 5's bracket. So again there are going to be 24 factors. So guys, just tell me, both 360 and 540 have 24 factors. I hope everybody understands. So I hope everybody understands that since 360 and 540 have the same number of factors, that does not at all mean that 360 and 540 have the same factors. There is a difference between having same number of factors and same factors. Is it so? Yes. So how can the two different numbers have all the same factors? That's not even possible. Now, for example, 540 is a factor of 540 and 360 is a factor of 360. 360 is not a factor of 540 and 540 is not a factor of 360. So definitely there are some factors which are going to be different. All right. Okay, now is the time that I think I should make a standard. So if there is a positive integer n which you express in the form of its prime factors and their powers, So the number of factors will be given by a plus 1 into b plus 1 into c plus 1 and more in case there are more. So let us take an example right up front. So what if the number is 420? Okay, I got a feedback that video is lagging and it is getting stuck in between. Everybody's feeling so? Uh, there is a bit delay in the video. Okay. Guys, in that case, I think I will need to restart my computer. So if it is too much of a problem, then I think I should do this. For that, the webinar will be ended and it will be started again within 5 minutes. Or if it is comfortably manageable, then we can get it going. Please suggest me. I'll do as you think. Okay, right now continuing with the number 420, is 21 into 20. 21 is made up of 3 and 7. 20 is made up of 2 square into 5. Okay, so I am directly writing the number of factors. The number of factors. So in the bracket of 3 there will be two numbers. In the bracket of 7 there will be two numbers. In the bracket of 2 there will be three numbers. In the bracket of 5 there will be two numbers. 24 factors of 720. So uh, the formula is just to signify, it's not that a number cannot have four. It's not that the number cannot have four brackets. So you just saw that 420 had four brackets and it was manageable, and we found the number of factors of 420 also. Okay, so all right. So now let me quote some questions based on this number of factors technique, prime factorization technique. So let us see. First question: what kind of numbers have odd number of factors? Let us try to answer this question. What kind of numbers have an odd number of factors? Okay, in order to seek the answer to this question, we must look at the formula. See, I'll not ask anything for which any previous knowledge is required or anything. So I ensure you and I assure you that the answer lies within what we just did, like in last 5-10 minutes. So the number of factors are made by multiplying a few brackets. This is the formula for number of factors. Okay, it's made by multiplying a few brackets. So basically a few numbers. So it's a product of a few numbers basically, right? So when is the product of a few numbers odd? When is the product of a few numbers odd? So what I'm trying to tell you is that this product is odd. So keep thinking. Think please. When do you find an odd product? When you multiply a certain numbers, you get an odd product, and all were integers. Is it possible that any one of them was 2 or 4 or 6 or 10 or 100, right? So when you multiply 4 or 5 numbers and you get an odd number as your product, right? It is imperative that all were odd, else you would not have gotten this kind of product. You would not have gotten odd product. All must be odd. Okay. So now just imagine, just understand that number of factors is odd, which means each bracket was odd, which means each power, also called exponent, was even. Understood the logic? Each power A, B, C must be even. And in what kind of numbers is A, B, C even? So let's make a few numbers like that. So what about 2 square and 3 square? What number is that? 36. Okay. What about 2 square into 3 to the power 4? Okay. So it is 81 into 4, 324. Okay. What about 2 to the power 4 and 3 square? It is 144. Okay. What about 2 square, 5 square? Okay. So this is 100. Alright. So what about 2 to the power 6? This is 64. 3 to the power 4, that is 81. So these are the kind of numbers in which all the powers individually are even. Right? What is the speciality of these numbers? So what is the speciality of these numbers? That can you see this? 324 is 18 square, 144 is 12 square, 100 is 10 square, 64 8 square, 81 9 square. So these numbers are these numbers are perfect squares. So what kind of numbers have an odd number of factors? Perfect squares have an odd number of factors. Got it? So all the perfect squares will have an odd number of factors. Okay. All right. So let us also understand something. So we just saw that perfect squares have an odd number of factors, etc., etc. So if there is a perfect square, then 2 square, 3 square, for example. So the powers are 2 and 2, so the brackets will become 3 and 3, etc., etc., etc. Okay, let us also understand why perfect squares should have even powers. So, why they are called perfect squares is because when you take a perfect square, take its under root, it comes out as an integer. When you take under root, square root of a number, you actually raise it to a power of half. Now, if the number is like this and the power is half, so you know that powers are multiplied. So this becomes this. Imagine if there is a number which is like this, and if you try to take its square root, that means raising the entire number to a power of half. This half will be multiplied with all the powers. What will happen if you get 2 to the power 5 by 2? It will become an irrational number. Leave alone a perfect square, leave alone integer, it will not even be a rational number. It will become an irrational number. Okay, so this way is also, it makes sense that each power of every odd number has to be even, divisible by 2. Okay, not only that, there is another note. There is another note about perfect squares that we'll understand a little later. Right now, I'm just writing it so that you can make a note of it about perfect squares. Not only the number of factors, but also some of the factors of perfect squares is also odd essentially. Some of the factors is also odd. Okay, so all right. Next question would be, okay, this you try to answer. So I gave you an idea how to look for an answer. So what kind of numbers have exactly three factors? What kind of numbers have exactly three factors? All right, some people able to find it. Interesting answers. So 4 and 9. These are examples. Yes, 4 has 3 factors, 9 has 3 factors. So one answer is multiple of 5. One answer is perfect squares. Not all the perfect squares, Aditya. Okay. Another answer is perfect square less than 10. Okay. No, that's not true, Sagar, because even 49 has only 3 factors, and 121 also has only 3 factors. Abhishek Kumar says composite numbers. Okay. And mostly the answers are correct. Not these answers, but other answers which I didn't talk about, they are correct. Okay. So the treatment of the question was similar. The expected treatment was similar. So what you had to do, you had to just think that the number of factors is equal to 3. 3 is a prime number itself. So if it were made by product of a couple of brackets, what kind of brackets would they be? 3 into 1 into 1, nothing else. They cannot be root 3 into root 3 into root 3, isn't it? That means this implies that there was only one bracket. Everybody understands this? There must have been only one bracket. There has to be only one bracket. Only then that could turn into 3. And how could it turn into 3? This implies only one prime. And this also implies square of prime. So the number must be of the form prime number square. In that case, while finding the number of factors, I am forced to do 2 plus 1 and full stop. That is all. So there are 3 factors then. So let me type the answer for you. It is the square of prime numbers. The squares of prime numbers have exactly 3 factors. Okay, let me take this 360 for you at some place where I can make questions on it. Okay, alright, so we have 360 in the center. Let me make a rectangle around it to protect it. Now, let me ask a couple of questions for 360. Okay, so let me ask how many factors of 360 are perfect squares. How many factors of 360 are perfect squares? Okay, this should not be the first question. I'm sorry. Let me change the question. Let me change the question. I will ask this question a little later maybe. So how many factors of 360 are even? How many factors of 360 are even? What do you have to say on this? Take a minute, take one good minute to analyze, to see what is required, to see what is given, to relate to what is required and what is given, assimilate the information. All right, so many answers. 6, 1, 18, 2, 14, 12, 24. Oh my god. All right. Okay. What do we need for the factors to be even? What do we need? Leave alone factors, for any number to be even. What do we need? We need 2. We need a 2 in the number to make it even. Okay. So 360 has 2 cube. Okay. Now let me see in detail. So 360 has 2 cube, 3 square and 1. So it is going to be like, in the 2's bracket there is going to be 1, 2, 4, 8. In the 3's bracket there is going to be 1, 3, 9. And in the 5's bracket there is going to be 1 and 5. Okay. Each number, sorry, one number from each bracket will be taken and will be multiplied to the other two to make a factor. This is what goes on. Okay, so just reiterating what has happened. So one number from each bracket is taken and we multiply the combination to make the number of factor, to make a certain factor. All right. So what if I pick 1 from the first bracket, and we are allowed to pick only one number from each bracket? So what if we pick 1 from the first bracket? Will I get a 2 in future in the subsequent brackets ahead? No, absolutely not. That means I cannot afford to leave all the even 2, 4, 8s and pick only 2 from the first bracket. So that tells me that there are only 3 numbers that I could pick from the first bracket, and once I have picked a 2 or a 4 or a 8 or an 8, then I am free to pick anything from the other brackets, and the product will definitely be odd. So there is going to be 18 even factors. I'm giving you 10 to 15 seconds to raise your doubt, and then I'll move ahead. Please write who has a problem. Sure, guys. Sure, guys. I will. Okay. So the process of finding, I will take you back again. The process of finding the factors to any number used to be this. So I would see what ingredients do I have. So in case of 18, I had 1, 2, and 2 threes. In the twos bracket, I had 1 and 2 only. In the threes bracket, I had 1, 3, and 9. Now each number multiplied with each number in the other bracket. But if you can see, pay attention to the detail that one number from each bracket was taken at a time. It was not that 1 into 2 and then 1 into 3 into 9, everything has been multiplied. No. One number from each bracket has been taken at a time. So we took, when we took 1 from the first bracket, I went to the next bracket. Okay. Similarly, in case of 540, we will take 1 from each bracket and make one factor. Okay. So if I do the same in my this case, let us see a little closely. Yeah. So I am allowed to pick one number from each bracket. So in the first bracket, if I pick 1, okay, then no matter what I pick from the other brackets, I'm not going to get an even product. Is it making sense? So I think I should not then pick 1 from the first bracket. I want to pick a 2 so that I am at peace now. Now, if I pick 1 or 3 or 9 and along with 1 or 5 from the other brackets, I have no tension. I have a 2, I have my product even. If I pick a 4, then also I am at peace. If I pick an 8, then also I am at peace. If I pick 1, then I'm not going to get a 2 further. So that is why, despite 4 numbers being present, 4 elements being present in the first bracket, I am going to choose 1 out of 3 of them, not 4 of them, because I cannot choose 1 from there if I want my factor, my product to be even. Is it okay now? Okay. Okay. I am going to ask you a similar question. May or may not sound similar, that's a different issue. How many factors of 360 are multiples of 5? Please try this, guys. Okay, guys. So hope you found the answer. Lot of answers again. And okay, so 12, 2, 9, 16, 3, 4. These answers I have got. These varieties of answer I mean. How many factors of 360 are multiples of 5? This was the question. Alright. So again, 360 has 2 cube, 3 square, 5 to the power 1. This time I'm only going to write 5 to the power 0 and 5 to the power 1. I'm going only elaborating the bracket of 5 because I wanted my factors to be multiples of 5. Okay, otherwise I am just writing in the bracket of 2 there are 4 numbers, in the bracket of 3 there are 3 numbers. In the bracket of 5 there are 5 numbers, but for me only one number is of use, that is 5 to the power 1. I want to pick only 5 to the power 1 because if I pick 5 to the power 0, 5 to the power 0 is not a multiple of 5, it is 1. So if I pick 5 to the power 0, I am not going to get a 5 in any from any of the other brackets. So I have to pick only one number from the third bracket, then I can pick anything from the other brackets. So it is going to be 4 into 3 into 1, 12 factors, multiples of 5. Okay, try this one and try well. I hope more correct answers this time. So, how many factors of 360 end with a 0 each? हर फैक्टर हर वो फैक्टर जो 0 से एंड होता है वो आपको पता करना है. How many factors each ending with 0? Okay, some fast people already started answering. 9 and 3 are the two varieties that I have got till now. Okay, so 9, 6, 3, 6, 3, 9. Okay, I'm getting answers as 6 and 3 and 9. Let us see. So, how do we get a 0 in the end of a number? How do we get a 0? Having a 0 at the end of the number means the number is a multiple of 10. for sure. Yes. And 10 is made up of 2 and 5. Do we have 2 in 360? Yes. Do we have 5 in 360? Yes. Can we have tens in 360? Yes, we'll definitely. And that was the question. How many tens are there in 360? Okay. So again, I have 2, 1, 2, 4, 8 in the first bracket, 1, 3, 9 in the second bracket, 1, 5 in the third bracket. Okay. So to have a 0 in the end of a factor, I need an even number, right? And even only I can get over here from these three. So I am allowed to pick 3 from the first bracket, not 1. Because if I take 1, no matter how many 5s are given to me, I will never be able to make a 0. I'll never be able to make a 10, basically. So I'm allowed to take 2 or 4 or 8 from the first bracket. And from the third bracket, I'm allowed to pick only one number, which is 5. I'm not allowed to pick 1. If I pick 1, I'll not get a 5. So no matter how many powers of 2 I have, I'll not be able to make a 10. So I have 10 now. Then I don't mind picking anything from the middle bracket. So 3 into 3 into 1, 9 multiples of 10. We can actually count since there are only 9. So there is 10, there is 20, there is 30, there is 40, there is 60, 90, 120, 180, and 360. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 9 factors of 360 which all end with 0 each. Alright, okay. Now I ask you what I mistakenly wrote the first time. So, how many factors of 360 are perfect squares? Tell me now. Alright, guys. So, yes, I'm very much here, Priyanka. I was just waiting for the people, even the people who are taking a little more time. It's important to give them time. They should not feel left out. Okay. So, there are only four perfect squares. That's what you are saying. Okay. Let us see. We will find out. So, okay, one thing is that we have in each bracket, we have at least one perfect square, that is power 0. Okay, so now I know that the numbers which are perfect squares have only even powers in their prime factors. So now 360's factors are also numbers. If I want them to be perfect squares, I want each power, I will choose the numbers very carefully so that their powers are even. So I will choose this, I will choose this in the second bracket, and only one in the third bracket. So how many can I pick? I can pick 2 in the first bracket, I can pick 2 in the second bracket, I can pick 1 in the third bracket. So a total of 4 perfect squares. You are absolutely right. A total of 4 perfect squares. Any doubt in this? So some people ask me that if I count manually, there are 5. 1, 2, 3, 4, 5. How can you say there are only 4? So then I have to remind them that you have counted 1 like twice, and you cannot count it like this. No, not twice, rather thrice. You have to multiply. Even their multiplication makes perfect squares. Pulkit says the number of odd factors is 6. You are right, Pulkit. There are 6 odd factors. But I didn't mean odd numbers, I meant perfect squares. They could be even, they could be odd. No, Pulkit, no, 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 no. You have got a little confused here. Odd factors are not perfect squares. Perfect squares have an odd number of factors. Then I asked even factors as in the nature of each factor to be an even number or the nature to be an odd number. So you found that there are 6 odd factors. So when I said odd factors, I meant the numbers like 1, 3, 9, right? 27, okay? 15, 5. Are these the factor of 360? Yes, these are the 6 odd factors of 360. You see, they are not perfect squares. Their nature is odd. They are odd numbers, right? When I connected the two words odd and perfect squares, I meant the counting of the counting of the counting of factors in case of a perfect square, the counting of factors that comes out as an odd number. So a perfect squares can have 3 factors, 5 factors, 7 factors, 9 factors. 11 factors, 1 factors, 99 factors, but not 2, 4, 6, 8 factors. So it's not about the nature of the factor, it's about um, the number of the factors. Okay, all right. Uh, a little back, you found out the factors of 540 also. Now I'm going to relate 360 and 540 in a question. So, how many factors of 360 are not there in 540? Okay, so I'm getting answers as 8, 6, 2, 1, 4, 12. Wow, that's quite a variety. Okay, so 360 has 2 cube, 3 square, 5 to the power 1. 540 has 2 square, 3 cube, and 5 to the power 1. Okay, so let us see the ingredients. So 360 has 2 to the power 0, 2, 4, 8. Okay. And 3 square has 1, 3, 9. And this has 1, 5. Alright. 540 has 1, 2, 4. That's it. 1, 3, 9 and 27 also. And 5 is same, 1 and 5. Okay. Our focus still is at 360. We were asked how many factors of 360 are not the factors of 540, not vice versa. So how many ingredients are there in 540 also? We have 1 over there, 2 over there. We have 1, 2, 4. These we have in 540 also. We don't have 8 over there. We don't have 8 in 540. We have 1, 3, 9 all there in 540. We have 1, 5. So we have everything but 8. So I think that is why some people answered 1, because 8 is the only factor which is not present 540 in 540. Okay, so you were partially right in answering 8. So 8 is the only ingredient which is not present in 540, not the only factor. It is the only ingredient which is not present in 540. So not only 8, anything that is made up of 8 in 360 will not be present in 540. So how many numbers of 360 are multiples of 8? This question practically asked you, right? So actual meaning of the question was how many factors of 360 are multiples of 8, isn't it? So you found that 8 is the only ingredient of 360 which is not present in 540. So how many multiples of 8? So in the first bracket I can pick only 1, then anything from the, in fact everything from the second bracket, everything from the third bracket. So 6 factors are there, are not there in 540. Also you see what is common in both. So 2 square, up to 2 square is common, up to 3 square is common, and up to 5 to the power 1 is common. Okay, how many factors does this number have? What is this number? This number is 180. And how many factors does it have? It has 18 factors. Interesting. So the maximum common number of factors in 360 and 540 are 18. 18 factors of 360 are there in 540 and vice versa. So we just found a lot of things over here. So we found that there are 8, the multiples of 8 which are present in 360 are the only numbers which are not present in 540, because 2 cube was the only ingredient which was not present in 540. So everything that was made up of 2 cube would not be there in 540. Point number 2. On the contrary, we tried to find out what all is common between the two of them, 360 and 540. So we found 2 cube into 3 square into 5 to the power 1. All this was common in the two of them. We tried to find out the number of factors of this number. This number was 180. We found 18 factors. Okay. Don't you think 180 is a common factor, and it is the highest common factor of 360 and 540? So we just ended up with the HCF while comparing the factors of two numbers 360 and 540. All right. So you just saw we started with prime factorization, trying to see the factor formation, the number of factors, right, and various questions, right, and we just sought a way to find the HCF also through this technique, right? So we'll take it from here the next time. Let me see your doubts. A couple of people have written. So Nikhil asks, if there are uncommon in each bracket, then how will we approach it? Uh, right, that is interesting. We can take an example. So Nikhil, if suppose I take an example like so 12 is made up of 2 square into 3, and then I have like I should take 60. 60 has 2 square into 3 into 5, and then I have 72, which has 2 cube into 3 square. So you want to know how do we approach in this case? Now we have different powers in each bracket. So 72 does not even have a 5, and 60 has only one 3 and two twos. 72 has three twos and two threes. Okay, so if I ask how many factors of 60 are not present in 72, so I have everything but 5. Okay, but if I ask how many factors of 72 are not present in 60, so in the bracket of 2, I have 8, which is not above. In the bracket of 3, I have 9, which is not above. Okay, so first I will take all the multiples of 8. So there are 3 multiples of 8. Then I'll take the multiples of 9. So there are 4 multiples of 9. But in the process, I counted one thing twice. So the product of 8 and 9 has been counted twice. That will be 6 numbers which are the multiples of 72 but are not present above. Okay, Chandrakamal asks me, but there is no ingredient of 27 in 360, but in 540, so 6 more added. No, 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 Chandrakamal. You have to see the language of the question. Question asked you how many factors of 360? Factors of 360 only. You had to keep your focus only on the factors of 360. The factors of 360 which are not there in 540. I don't care what n number of factors in 540 which are not present above in 360. The focus, the subject of the question were the factors of 360. We only had to see what 360 factors are not present down in the 540. Had the question been how many factors of 540 are not present in 360, then we would have taken 27 into consideration. All right, guys. So this was a good discussion. So I think we learned quite a bit in this class. Remainders could not be touched. I was unable to estimate time beforehand. So now I know it takes one full class of multiples and factors, yet yet it needs some more time. Uh, all right, people are still asking me how it came as 6. How what came as 6? Actually, there are two answers. One is the case of 60 and 72. Okay, about 72. Yes. So actually, Nikhil earlier asked me that in case of 360 and 540, there was only one ingredient which was uncommon. So I quickly found out that there are going to be six multiples of 8. But in case I took 60 and 72, so I saw that there are two ingredients, one in the bracket of 2 and one in the bracket of 3, which are not present above. Okay, so Nikhil asked me what would happen in this case. So first I took the multiples of 8, the case of 8. I found 1 into 3. There are three factors of 72, which are multiples of 8. Then I took the case of 9. I found there are four multiples of 9, which are factors of 72. But if I just take 3 and 4 and then I said 7, so out of these 7, 8 and 9 has been counted here also and here also. So this should have been counted just once. So I should subtract 1 from 7 and I should say 6 numbers, 6 factors of 72. Why I subtracted 1 is because I wanted to include 8 into 9 but not twice. They were included twice when we added 3 and 4. So I needed to exclude one of the repetitions. Okay, I hope now it is clear. All right, guys. So we have to call it a day over here, and I will start from this point: discovery of HCF through prime factorization. How HCF will lead to finding LCM. Also, we will see all that. We will solve certain number of questions, and then we'll get an introduction of division and remainder also in the very next class. No, next class is planned to be the continuation of average basics. So maybe next to next class then. All right then, keep learning. Thank you so very much. Bye. Take care.